So here we go, linear regressions. We're going to learn how to take a linear set of data and match a linear function to it. Here we go. So the scenario here is we're going to have a table. Here's a table. And what this table means is the X values are, let's say, the scores that students made on a homework assignment. And then the Y values represent their score on a test for that unit. So this student made a 77 on homework, made a 67 on the test. This student made an 88 on homework and an 83 on the test. This student a 77 and a 70, et cetera, et cetera. All right. And so what we're going to try to find is we're going to try to answer the question, what if a student makes a 90 on the homework? What would we expect for them to make on the test? So there's an educated answer to this, and we need to use regressions. All right. So here's what we're going to do. The first thing is I'm going to take that data and I'm going to copy it into a table. So I'm going to go right here to add item in Desmos, and I am going to click on table. So I'm going to add a table, and usually this will say X1 and Y1. I've made multiple tables, so that's why I had different numbers. And I'm going to very carefully copy these values down. So 77, 88, 77, 89, 73, 80, 82, 58, and 87. And now I'm going to work my way down the Y column. So 67, 83, 70, 94, 70, 77, 85, 46, and 79. Okay, and those are my values. All right, so now I've entered this table, and Desmos now recognizes it because this is just an image that I had copied. Okay, so I'm going to go ahead and unclick my image. And the next cool thing about these tables is these are all very large X values and Y values. My window usually goes just from -10 to +10 for both X and Y. So I'm going to click on this little magnifying glass called Zoom Fit. All right, and when I do that, well, let me turn these other things off so you don't get a wrong idea here. All right, when I click on that, boom, my data shows up. All right, for example, there's 58, 46, that student that made a 58 on homework and a 46 on the test. Okay, so all my data right here, and it appears that the data is rising. Maybe the higher I do on my homework, the higher I make, higher score I get on the test, right? But we're gonna find which line best fits this. All right, so linear functions, remember, y equals mx plus b. All I'm going to do is I'm going to type in y equals mx plus b here on Desmos, except I'm going to modify it a little bit. All right. What I'm going to say instead of y equals mx plus b is, well, if you pay attention to your table, it says x1 and y1 instead of y and x. So I'm going to say y1. I'm going to change my equal sign to this tilde symbol, and I'm going to say x1. So it's a little modified. It's still y equals mx plus b. All right. And now you see a line go across it, all right? So it tells you, gives you some statistical information, all right, that we don't comprehend yet, but it does give me the parameter. It says m, the slope, is 1.339, and b, the y-intercept, should be -31.24. Now I'm going to copy this information to the nearest hundredth, all right, to the nearest hundredth, all right, and let's check it out. So my slope, I'm going to say 1.34. All right, nearest hundredths. That's two numbers after the decimal. And I'm going to subtract the y-intercept minus 31.24. And now I'm going to graph that line. You can see that it's the same line. Now it's in red. And I'm going to use function notation. I'm going to say f of x instead of y equals. That way I can evaluate, right? So in my very next cell, I have typed f of 90, and it tells me f of 90 is 89.36. In other words, if a student makes a 90 on homework, they should expect to make about an 89 on the test, okay? Another way that you could do that evaluation, right, is, well, you could do it by hand. You could say 1.34 times 90, that gives me 120.6, and then take away 31.24, and you get 89.36 to the nearest whole number, that is an 89. Okay, so that's evaluation with function notation or by just substituting. And so that is how you find a linear regression model and how you use that linear regression model to answer questions.